So, last time I briefly talked about refraction, or we talked about reflection, and then I mentioned refraction. Okay? So, refraction is, thank you, when light bends and changes direction. Okay, that's refraction. So, in this example, we have a clear prism. The light goes in here, bends in this direction, and then when it hits the end, it bends back. Excuse me. So that is refraction. Now, when light goes from one medium to another, whether it's water, air, air to a prism, something like that, the light changes speed. Usually it slows down, but not always. So how much the light, well in this case slows down or speeds up, is called the refractive index. So basically it's a measure of how much is the speed of light going to change as it passes through some object, some different medium. So, the speed of light in a vacuum is 299,792,458 meters per second. Or more commonly in physics, we use the symbol c to represent the speed of light, and we simplify that to just 3 times 10 to the 8 meters per second. Okay? So this is the actual speed of light. This is just what we use generally in our calculations. So to find the refractive index, we use the formula, the refractive index n, which is equal to the speed of light in a vacuum divided by the speed of light in the material. Now, we know the speed of light in a vacuum, right? That we know. But these other two, we don't necessarily know, right? If I said, what's the speed of light in water, I'm sure you probably couldn't answer that question right away. But with questions like this, normally you're given one of two things. You'll either be given the speed of light, or you'll be giving the refractive index. And then you can find the speed of light in the material. Okay? But the formula is fairly straightforward. So n equals c over the speed of light in our material. Okay? So, the water has a refractive index of n equals 1.33. So this means that light travels 1.33 times faster in a vacuum compared to water. So we can find the speed of light in water. So to do that, we use our formula. Okay? So I know the speed of light in a vacuum, and I know n, in this case, which is 1.33. Now I can find the speed of light in water. So 1.33 equals 3 times 10 to the 8 over x, we'll call it. X being our speed of light in water. Then we just solve this, and we get 2.26 times 10 to the 8 meters per second. So that's 226 million meters per second. That's how fast light travels in water. Make sense so far? No questions? David, you awake? Did you do well on your test?
Which test? It wasn't a test, it was homework.
No. You have a question? Say that again? I could. Sure. I'm currently recording this, and I'm going to put it on YouTube. What?
Are you recording voice as well?
Yes.
So right now what I'm saying...
Actually, it probably could only hear David if he talked a little bit louder.
Will it hear me now?
I have no idea. We'll test it later, and we can laugh at it, and it'll be a good fun.
Broadcast the Periscope.
You should have Periscope.
Yes.
No. So, Snell's law. Snell's law is something that uses the refractive index. So, we talked about when we were looking at refraction or even reflection, right? If we had some medium, light going in this way, and then it refracts in another direction, So we talked about this being the angle of incidence, so that's I, and this here being the angle of refraction, which is R. Okay, and we talked about that last time. So this is used to relate the size or the change in these angles. So being able to find the different angles. So this law uses the refraction index to come up with this formula. That was up there. No, maybe not. Okay. So n equals sine of I divided by the sine of R. So n being your refractive index, I being the angle of incidence, and R being the angle of refraction. So if you know your refraction index, then you can, and you know the angle of incidence, let's say, you can find the angle of refraction. So you can see exactly how far the light will bend when it hits the other material. Okay, that is Snell's law. Let's just make sure. Okay. So, a ray of light strikes a glass box, block, with an angle of incidence of 45 degrees. The refractive index of glass is 1.6. So what is the angle of refraction? So for this, we use our formula, which I put either here. Nope. Okay. So first we write out what we know. So our angle of incidence, I, is 45 degrees, N is 1.6, and R is a question mark because, we haven't found that yet. So we write out our information from our question. Next, we write out our equation. And here we have N equals sine I over sine R. Now our goal is just to solve for R. So most of you probably already know how to solve this, but I'm going to take it one step at a time. So first we solve for sine R. So sine R is equal to sine of 45, which is our angle of incidence, divided by N, which is 1.6, which is our refractive index. So sine of R is equal to 0.442. And then lastly, I solve for R itself by taking the sine inverse. So you'll remember that from when we did trig. Okay? When we talked about trigonometry, I talked about using your sine inverse, cos inverse, things like that. So whenever you need to solve for a variable that is with, well, in this case, sine, right? If you need to get the variable by itself, you have to use sine inverse of whatever your answer, whatever you have on the other side of your equal sign. So in this case, it's 0.442. So R is equal to sine of negative 1 of 0.442, which is 26.2 degrees. So if I were to draw this as best as I could, the light's coming in at 45 degrees here. And then, actually this one, in this case. This one would be 26.2. I can check after, make sure that I got that quite right, but I'm pretty sure that is. I'm wrong. I lied. The angle of refraction is from 90 degrees. So it's 26. So, do we have any questions about this? You with me, David? Okay. You got this? No problems yet? A little? Okay, I think I have one more, which is length. That's convenient. Okay, so there are no questions about refractive index, Snell's law. Okay, then I'm going to